In this video, we're going to solve nonlinear inequalities. So let's first take a look at this problem right here. We have x squared minus 6x minus 30 is greater than negative 3, and we need to solve for x. So what we want to do is we want to move everything to one side. So x squared minus 6x, and you add 3 to both sides, you get negative 27 is greater than 0. So these two are still equivalent. Now, is this factorable? Yes, it is. So x minus 9, x plus 3 greater than 0. Now, when you solve this, pretending that this is equal to 0, you get x equals 9, and you get x equals negative 3. Now, these two are important because it will help us to find the solution. So now we're going to create this thing called Sine Chart. And we're going to put negative 3, and we're going to put 9 in order. Make sure these are in order, smaller to larger. Now, what we need to do is we need to choose test values. So what do I mean by that? You have 9. What are the numbers that are greater than 9? That's 10, 11, 12, and so forth. That's infinite number of possibilities. So choose a nice number that's greater than 9. Let's say 10. And plug in over here to a factor form. When you plug in 10, you get positive 1. You get positive 13. So positive times positive is positive. The sign is all that matters. That's why it's called the Sine Chart. This result will be true even if you choose 20 and plug it in. You still get positive. So basically, any number you choose that are greater than 9, you plug it in, you end up getting positive. Now, what is a nice number to pick from here? 0. 0 is always nice. So you get, when you plug in 0, you get negative 9 times 3. Negative 9 times 3 is negative. That means any number that you choose between negative 3 and 9 and you plug in over here, you end up getting negative. Now, what's the nice number to test from here? Let's do negative 10. Plug in negative 10, you get negative. Plug in negative 10, negative. Negative times negative is positive. Now, notice, when is this greater than 0? This is greater than 0 whenever it's positive. So our solution will be whenever x is less than negative 3 or whenever x is greater than 9. Now we're going to use our interval notation since this is precalculus. How do we write that using interval notation? Well, it's going to be negative infinity to negative 3, not including negative 3, so you got to put parentheses. Notice, if this was underlined, then you should have underlined right here too, and you have to use a bracket. Or is a union symbol. And how do we write x greater than 9? Is 9 to infinity. So here are our solutions. This is our solution right here. And again, you got to be able to do it both ways. Now, graphically, what does this mean? Graphically. Well, using our Desmos, let's graph this and see what happens. And remember our solution. So what I did was I graphed y equals x squared minus 6x minus 30, which represents the left side of the inequality, and y equals negative 3, which represents the right side of the inequality. Now look at this graph. The blue line is y equals negative 3. So when is x squared minus 6x minus 30 greater than negative 3? Well, that only happens when x is less than negative 3 and or when x is greater than 9. Now, if you could think of it like this too. Then when is x squared minus 6x minus 30 less than negative 3? Well, that happens when x is greater than negative 3 and less than 9. Now let's solve this example. So again, we want to, now in this case, we want to know when this 2x squared minus 10x is less than or equal to 2x minus 16. So in order to solve this, we are going to move everything to the left side. And let's combine the like terms. All right, now we could divide everything by 2. Now, since you're dividing by positive 2, you don't have to change the direction of the inequality sign. If you were dividing by negative, then you have to change the sign. So when you divide everything by positive 2, you get x squared minus 6x plus 8. Direction of the inequality sign does not change since you are dividing by positive. Now, this is factorable, so you get x minus 4, x minus 2, that's equal to 0. So now, if pretending this is equal to 0, you get x equals 4 and x equals 2, which we're going to use it for Sine Chart. So you get 2 and 4. Now we have to choose the test values to plug in over here. So just choose any nice number, let's say 10. When you plug in 10, you get positive times positive, which is positive. What over here? 3. 3 is a nice number to choose. You get negative times positive, which is negative. What over here? 0. Negative times negative is positive. Now, this is less than or equal to 0. So when does that happen? That happens when the sign is negative. So solution is x has to be greater than, less than or equal to 2 and greater than or equal to 4. Now, why did I draw underline here? Because this has underline. Now, how do you use the interval notation to represent this? Well, now you got to just bracket 2, comma, 4. This means all real numbers from 2 to 4, which is the same thing as this. Now let's see what happens graphically. So I'm going to graph this 2 separately and find out when this is less than or equal to this graph. So I got 2x squared minus 10x as a red graph and then 2x minus 16 as a blue graph. Now notice, when is 2x squared minus 10x less than or equal to 2x minus 16? Well, that happens when 2x squared minus 10x is below 2x minus 16. That happens from 2 to 4, including 2 and 4. So graphically, it also makes sense. Now, let me ask you this. For what values of x is 2x squared minus 10x greater than or equal to 2x minus 16? That happens when the red graph is above the blue line, which will be negative infinity to positive 2, including 2, and 4, including 4 to infinity. Now let's take a look at this example. You got x squared plus 5x plus 8 is less than 0. Now if you look at this, unfortunately, we cannot factor this out. So pretending this is equal to 0, since this is not factorable, we're going to use quadratic formula. So a is 1, b is 5, and c is 8. So x equals negative 5 plus or minus square root of b squared minus 4ab C all over 2a, which is 2 times 1. So let's simplify this. You get negative 5 plus or minus square root of 25 minus 32. And you should notice we're in trouble because this is not a real number. This is going to be a complex number because you have negative inside the radical. So you get negative 5 plus or minus I radical 7 all over 2. We cannot solve for x, so when you have a sign changer, sign chart, we don't have any numbers to put in over here. So what we're going to do is, let's just try any number. Plug in 0. When you plug in 0, what happens? You get positive 8, right? What about 2? You get positive. What about negative 2? You get positive. So it doesn't matter what number you choose. Any number you choose, you always end up getting positive. So now, when is this less than 0? Since this is positive, that will never happen. So what can we conclude? No solution. Or we use this symbol, 0 and slash, which represents the empty set. This is a notation for no solution. Now let's graph this and see what happens. I'm going to graph this and 0, y equals 0, and see what happens. So as you can see, you got y equals x squared plus 5x plus 8 as a red line, and then y equals 0. That's the x-axis. Now, x squared plus 5x plus 8 is always above y equals 0, meaning that no matter what x is, this will be always greater than y equals 0. So therefore, we did not have a solution because we wanted to find a solution when this x squared plus 5x plus 8 is less than, below 0. But that never happens. Now, what if I change the problem? Let's say I'm going to make it as greater than equal to. Then we will have a solution. What will be the solution? Well, since we already did the work, when is this greater than equal to 0? Well, that happens when this is positive. And as you can see from the sign chart, no matter what number you plug in here, you always get a positive number. So the solution will be all real numbers. Or you could say negative infinity to positive infinity. And graphically speaking, notice x squared plus 5x plus 8 is always greater than or equal to 0. That's why the solution will be all real numbers. Now let's take a look at this example here. We got to find when x squared minus 10x plus 25 is greater than 0. Fortunately, this is factorable. This is x minus 5, and this is x minus 5. So we have x equals 5 that can be used in our sign chart. But notice, when x equals 5, when you plug in 5, this whole thing becomes 0, right? And 0 is not greater than 0. So keep that in mind. What is a good test value from here? Let's plug in 10. When you plug in 10, you get positive. What about over here? 0. When you plug in 0, negative times negative is positive. So we want this to be positive because it has to be greater than 0. When does that happen? That happens when x is less than 5 or when x is greater than 5. And how do we use our interval notation to represent this. It will be negative infinity to 5, not including 5, or 5 to infinity. Again, we cannot include 5 because at 5, this becomes 0, and 0 is not greater than 0. So what does it mean graphically? So graphically, we need to find when x squared minus 10x plus 25 is greater than 0, right? So notice x squared minus 10x plus 25 is above y equals 0 everywhere except when x equals 5. That's why the answer came out like that. Now, what if I change the problem to less than or equal to 0? This is positive. So I need to erase this. So this is positive, that's positive. We want that to be negative and negative, but that did not happen. But it says less than or equal to 0. So that only happens when x is what? X equals 5. So this is only true when x equals 5. So only solution we have is 5. X equals 5. And graphically speaking, again, when x equals 5, that's when x squared minus 10x, the y value of x squared minus 10x plus 25 is equal to 0.